Welcome to all of you, my students. Today I will deliver lecture number 17. Let's start. So in today's lecture, we will discuss some results on the lattice of congruences, lattice of equivalences. See, this is the set of all equivalences on a semigroup S, and this is set of all congruences on a semigroup S. These are the two sets. These sets forms complete lattice. See, if we take rho comma sigma belonging to these sets in bracket like this, then order is defined like this. Partial order is defined like this when rho is contained in sigma. So least upper bound is what? Rho union sigma hash when rho sigma, for every rho sigma belongs to set of congruences, and rho join sigma is rho union sigma E for every rho comma sigma belongs to set of equivalences, while least upper bound is defined like this: rho intersection sigma. So basically partial ordered is this, and both forms complete lattice. Complete lattice. And here S cross S is the maximum element and 1S is the minimum. This is the maximum element. Maximum element, and this is the minimum element. That is equality relation. Now it is very interesting to see that these two are equal to each other. These two are equal. How? Let's see. See, rho union sigma hash is defined as rho union sigma C E. As we know that R hash is what? R C E. Basically, what is R hash? R hash is what? R hash is the smallest congruence on R containing R, correct? And what is RE? RE is what? The smallest equivalence relation on a semigroup S containing R, isn't it? This is R hash, this is RE. These two notations we already know. In the previous lecture I have discussed what is R hash and what is RE. So R hash is what? RCE. Now we can calculate here. See, rho union sigma CE. It is what? Rho C union sigma CE. And what is rho C? What is rho C? Rho is what? Rho is what? Congruence, because rho join sigma is rho union sigma hash. For every rho, sigma belongs to set of congruences. That when rho and sigma are congruences, here rho and sigma are equivalences, here rho and sigma are congruences. So when rho and sigma are congruences, it means rho and sigma are what? Compatible. And when rho and sigma are compatible, then rho C is equal to what? Rho, and sigma C is what? Sigma E. Since rho sigma are compatible, they are left compatible as well as right compatible. So we see rho intersection, rho union sigma hash is equal to rho union sigma E. So it means that the join of rho and sigma will always be rho union sigma E, correct? And rho meet sigma is always rho for every rho sigma belongs to psi s, or you can say this CS. So join and meet is fixed, whether we talk about the set of all congruences on a semigroup S, whether we talk of set of all equivalences on a set X. Join and meet is fixed. What is join? Join is rho union sigma is rho join sigma is equal to rho union sigma E, and rho meet sigma is equal to rho intersection sigma. This is for every rho sigma belongs to lattice of equivalences. Either we talk about lattice of equivalences or we talk about lattice of congruences. In both cases, meet and join are these, correct? And both forms a complete lattice. So now we do result, that is the proposition 1.5.11. Let rho comma sigma belongs to lattice of equivalences or lattice of congruences. Then A comma B belongs to rho join sigma if and only if for some n belonging to set of natural number there exist elements x1, x2 dot so on x2n minus 1 in S such that A comma x1 belongs to rho, x1 comma x2 belongs to sigma, x2 comma x3 belongs to rho, and dot so on x2n minus 1 comma b belongs to sigma. equivalently, I say equivalently A comma B rho join sigma is equal to rho composition sigma infinity. See, rho sigma, either you take rho sigma from the lattice of equivalences on a semigroup S, or you take rho comma sigma in the lattice of congruences on a semigroup S. Correct? I mean to say that whether you take equivalences rho and sigma, or you take congruences rho and sigma, rho join sigma is equal to what? Rho composition sigma की power infinity. This you have to prove. Correct? So both are equivalent. Now try to think by yourself that how these two statements are equivalent to each other. Here a statement is written as A comma B belongs to rho join sigma if and only if for some n belongs to set of natural number there exists element x1, x2 dots on x2 n minus 1 in S such that A comma x1 belongs to rho, x1 comma x2 belongs to sigma, x2 comma x3 belongs to rho, dot so on x2n minus 1 comma b belongs to sigma. So one statement is from here, that is this. So this statement and what I have written in short, that is rho join sigma is equal to rho composition sigma की power infinity. These two statements are equivalent to each other. So try to think by yourself that how these two statements. I am saying that this whole statement is equivalent to just only this. That is, if we prove rho join sigma is equal to rho composition sigma की power infinity, it means that we have proved this. So try to justify by yourself. Okay, I will prove that how these two are equal to each other. Correct? See, as we know that when rho and sigma belongs to the set of lattice of equivalences or congruences, rho join sigma is same, isn't it? What is rho join sigma? We know that rho join sigma is equal to rho union sigma E for every rho comma sigma belongs to lattice of equivalences on semigroup S or lattice of congruence on semigroup S. Correct? We know that. And basically what is this? This is equal to what? Rho union sigma union rho union sigma inverse union 1s infinity whole power infinity. Correct? So this is what rho union sigma inverse union rho inverse union 1s infinity. Correct? Now what is rho inverse? What is sigma inverse? What is rho inverse? Sigma inverse is sigma, rho inverse is rho. Why? Because rho and sigma both are symmetric. Being congruence or equivalence, they are symmetric. So rho union sigma union rho union 1s infinity. Now it is equal to what? It is equal to finally rho union sigma infinity. You can just write the logic, since rho is equal to rho inverse and sigma is equal to sigma inverse. Correct? So basically rho join sigma is what? Rho union sigma की power infinity. So we show that rho union sigma की power infinity is equal to rho composition sigma की power infinity. We show this. This is, if we show this rho union sigma की power infinity is equal to rho composition sigma की power infinity. If we show this, then we are done, because we have to prove this. Correct? Now you see, rho is contained in rho's composition sigma. It's obvious, isn't it? Because rho is It's trivially true. You can take a limit here, you can show here, and since and sigma is contained in rho composition sigma, therefore rho union sigma is contained in rho composition sigma. Now rho union sigma is contained in rho, it implies what? It implies that rho union sigma की power n is contained in rho composition sigma की power n. Correct? Now it implies that rho union sigma की power infinity is contained in rho composition sigma की power infinity. So one part is done. Now we do the converse part. Since rho is contained in rho union sigma and sigma is contained in rho union sigma, therefore rho composition sigma is contained in rho union sigma composition rho union sigma. It means that it is rho union sigma square. Correct? So we have shown that rho composition sigma is contained in rho union square. It implies what? It implies that rho composition sigma की power n is contained in rho union sigma की power 2n, and it implies that rho composition sigma की power infinity is contained in rho union sigma की power infinity. Now from 1 and from 2, because this is for every n belongs to set of natural numbers, correct? So from 1 and 2 we conclude that from 1 and 2 rho union sigma rho composition sigma की rho union sigma की power infinity is equal to rho composition sigma की power infinity, and this is what? This is the rho join sigma. So we have proved that rho join sigma is equal to rho composition sigma की power infinity, and which is equivalent to this. And now try to think, all of my students, try to think by yourself how this condition is equivalent to this condition. I think it's very easy. If you do some steps, you will go through it. So try to think by yourself. Now there is a corollary 1.5.12. What is the meaning of corollary? We have done here the proposition, and now we do the corollary of this proposition. Corollary means that is the deduction of the result. We do some result, it has some implication, it has some use, and we call as a corollary of that result. So we will do corollary 1.5.12. Let's see what it is. Corollary 1.5.12. That is, they are saying that let rho comma sigma belongs to lattice of equivalences or lattice of congruences, such that rho composition sigma is equal to sigma composition rho. Correct? Then they are saying that then they are saying that rho join sigma is equal to rho composition sigma. So we have to prove this. rho join sigma is equal to rho composition sigma. See, we already proved that what we have already proved. We already proved that rho composition sigma is equal to rho composition sigma ki power infinity. Rho join sigma, we have already proved this, correct? It means that it is, you can say that rho composition sigma n 1 to infinity, like this. So we have already proved this thing. Now you see, rho composition sigma square, if you calculate, it will be what? It is rho composition sigma composition rho composition sigma, correct? Now when rho and sigma commute with each other, correct? So we can just club all rho's one side and all sigmas all together. So it means that it is equal to rho composition rho and it is sigma composition sigma, correct? As we know that rho and sigma are transitive, because being equivalence or congruence, they are transitive relations. So when rho is transitive, it is equal to rho, and when sigma is transitive, it is equal to sigma. Since rho and sigma are transitive relations, always remember, when rho is transitive, then rho composition rho is equal to rho. When rho is transitive, if rho is transitive, then rho composition rho is rho, correct? So this is the rho composition sigma. Similarly, rho composition sigma ki power n, if you calculate, it will come as rho composition sigma. So rho join sigma is equal to union 1 to infinity rho composition sigma ki power n. Now it will be 1 to infinity. So it is rho composition sigma. So it is rho composition sigma, because when there is no n, whole rho composition sigma ki power n is equal to rho composition sigma, so it will become equal to rho composition sigma. So rho join sigma is what? Rho composition sigma, correct?